All right, welcome back, everybody. Today we are going to be going through the review for your test. As always, I will go through and do the evens, and I'll save the odds for you to get some practice on your own. I will post a full answer key of this, though, so that you can check your work, since we're not going to be turning this one in for actual homework points. The first one here, we're talking about special right triangles. So remember, two kinds of special right triangles, 45, 45, 90, which is what this one is. And there's a rule for them. Whenever you have a special right triangle, if you take the leg length, or a 45, 45, 90 triangle, and you multiply it by the square root of 2, that's going to be equal to the hypotenuse. Now, in this situation, we're not even looking for the hypotenuse, because the hypotenuse would be this side over here. Instead, when it's a 45, 45, 90 triangle, we do know that the side lengths also need to be the same, so this will be 9. Moving ahead to problem number 4. In this situation, we know the short leg, and we actually have our two formulas that you're going to want to commit to memory, and those two are that the hypotenuse is equal to the short leg of the triangle times 2, and that the long leg of the triangle, I call it LL, is equal to the short leg times the square root of 3. Since we know the short leg here, this is going to be a relatively easy process. If I take the square root of 7 and I multiply it by 2, that will give me 2 square roots of 7, which will be the hypotenuse. If I take the square root of 7, which is the short leg, and I multiply it by the square root of 3, that will give me the long leg. Square root of 7 times square root of 3 will be the square root of 21, which can't be simplified or reduced, so we're done. Moving ahead to problem number 6. Over here, this is not a special right triangle because this is 70 degrees. If it's 70 degrees, then we don't have any idea in terms of the relationship between it. Now, one thing we can do is, assuming this is a 90-degree angle there, then what we can do is we can use trig to help us solve it. So opposite of the 70-degree angle is our 40 side. And, of course, this is our hypotenuse over here because it's across from our right angle. So since we know the opposite and we want to find the hypotenuse, we're going to use sine to do this. So sine of 70 degrees will be equal to the opposite, which is 40, over the hypotenuse, which is x. Now, to solve this, I need to get x out of the denominator, so I'm going to multiply both sides by x. So I'm going to get x times the sine of 70 degrees is equal to 40, because these two will cancel out. And then I want to get x alone, so I'm going to divide both sides by the sine of 70 degrees. That will make these two cancel, and I'll be left with x equals whatever this is. So punching this in on our calculator, 40 divided by the sine of 70 degrees gives us an answer of 42.57, which is what x is equal to in this problem. And that answer makes sense because it's bigger than 40, and since it's the hypotenuse, we know that that's going to have to be the case. So that's one way we can kind of do like a quick check on it. Doesn't guarantee anything, but it does help. Looking at problem number 8 over here, we're talking about the 6 trigonometric functions. Find the exact value of the 6 trigonometric functions given the following information. So first off, I like to just outline what these all are. So sine is always going to be the opposite over the hypotenuse. Cosine is going to be the adjacent over the hypotenuse. And tangent is going to be the opposite over the adjacent. And of course, cosecant, cotangent, and secant are just flips of those. So in this situation, we are using angle theta here, so this will be our opposite side as it opens up to that side. Our hypotenuse is always across from the right angle, and whatever's left is your adjacent side. So in this situation, opposite over hypotenuse would be 6 over 7. For the next one, adjacent over the hypotenuse would be the square root of 13 over 7. And opposite over the adjacent would be 6 over the square root of 13. Now, officially, this is not good enough because we need to rationalize that if we end up with it on the bottom. So I'm going to just pull this off, 6 over the square root of 13. To rationalize this, we're going to multiply top and bottom by the square root of 13. Doing so will give us 6 square roots of 13 over 13, which will be the rationalized form of this. Now I'm going to put a box around this just so that I don't forget about it. That's where we originally started, and that's going to be helpful to us in a minute. So remember, for cosecant, cotangent, and secant, they're essentially just flips of the previous ones, but you got to get them kind of in the right order, and I can see that they actually tried to mess with us a little bit. So tangent and cotangent are opposites. They're flips of one another. So what I want to do in this situation is I'm going to actually go back to the original, because if I were to have flipped this, the square root of 13 over 6 would have been acceptable, and we don't need to do any extra work. Sine does go with cosecant, though, so we can flip this one into be 7 over 6. And then cosine goes with secant, so 7 over the square root of 13 would be my answer there. Now, of course, that does put a square root on the bottom, so we're going to have to do more work before we can finalize that. Multiplying both sides by the square root of 13, square root of 13, we get 7 square roots of 13 over 13. That is what we will put on the line here, because we were told up top to simplify any radicals and to rationalize the denominator. So it's very important that you know that sine goes with cosecant, tangent goes with cotangent, and cosine goes with secant. Looking ahead to problem number 10, now we get to those word problems. It says, draw a picture that represents the angle of depression and the angle of elevation. Well, two different ways to do it. If I had a person that was standing on the ground here, his normal line of sight would come out over here. If he decides to tilt his head up to look at a cloud, this would be an example of an angle of elevation. Now, let's look at that from a different perspective. If you're in an airplane, you're flying. Man, look how good this airplane looks. We're flying. Ooh, it's going good. I think I'm actually going, I don't know. Anyway, I'm looking out. I'm the pilot, and I decide I want to look down to see a lake. So as long as I'm looking down, my head goes down, that's going to be an angle of depression. Well, here's that lake. Maybe a little boat in there. I don't know how to draw a boat. Sailboat. Great. This would be an angle of depression. Looking ahead to problem number 12, it says a building 150 feet tall. Here's my building. I like to just draw it as I get it. 150 feet tall is going to cast a shadow that is 12 feet long. Here's the shadow. What is the angle of elevation from the ground to the top of the building? So coming over here, if I was on the ground and I looked up towards the top of the building, what is that angle of elevation? We'll call it theta for right now. Of course, this does form a right triangle for us, so we're going to be able to use right triangle trig. So coming over there, we do know what's opposite of that and what's adjacent to that angle. So we are going to be using tangent. So tangent of my angle, which I don't know, is equal to the opposite, which is 150, over the adjacent, which is 12. So since we are looking for the angle here, we want to use tangent inverse. Tangent inverse of the angle is equal, or I'm sorry, of our ratio is equal to the angle. So coming over here and punching that in, tangent inverse of 150 divided by 12 gives us our answer of 85.43 degrees. So theta is equal to 85.43 degrees. So that is how far I'm going to need to look up in order to see the top of the building if I'm standing at the edge of the shadow. It looks like that was the last even problem for me to work, so the rest of the odds are there for you. If you have any questions about this, please do not hesitate to reach out. Remember, there will be a full answer key that is posted for this that you can utilize to check your work. Thank you guys for watching. I hope you have a great day and are doing well.